So in this class, we will discuss rotary intersection. So before entering into the discussion, we have to briefly understand the terms involved in rotary intersection. Suppose this is the rotary and we have R as the radius of rotary, or you can call it roundabout also. And as we approach the rotary, we have entry here. Right? This is an inscribed circle. And we have entry radius. This is a combination of two radius, that is entry radius, the curve of this one, entry radius, and we have exit radius. Generally, radius at entry of the rotary, this curve, radius at entry is less than radius at exit. Exit of a rotary. This is entry, this is exit. Similarly for all the approaches. And now what happens is, and there is a section where the vehicles weave like this, means the vehicles traveling here and rotate and go like that. Similarly for this approach, there is a weaving section, right, where the vehicles will not go straight and they will weave like this. Similarly for all the approaches, we have a weaving section. If at all there is no rotary, then we may have different conflicts, crossing conflicts. So that we have seen in the last class, where we have different types of conflicts: crossing, diverging and merging. And now there are no crossing conflicts, because the vehicles coming from here can view the vehicles which are coming from here and here. So there are no crossing conflicts, only diverging and merging conflicts are there. And now we will discuss about them. We have entry width. So entry width, take it as E1. As the traffic approaches the rotary, the width of the curve has been increased to reduce the width of the road. So as the width of the road reduces, the speed approaching the rotary also reduces. So we will reduce this width, and this is called entry width. And where we exit the rotary, we have exit width. And we have weaving section and non-weaving section, and this is weaving length, take it as L, and weaving width as W. So generally weaving width is equal to E1 plus E2 by 2, that is average of entry width and exit width plus 3.5 meter. And if the data is not given, L is taken as 4 times width of the weaving section. So here we have width of the weaving sections, and this is width of the non-weaving section here, and this is weaving section. Is it clear up to now? Now we have two types of conflicts, as I have already told you, diverging and merging, and we have turning moments left, right, and there are crossing moments also. See, this is A, where the traffic is turning left, and say this is D, here, where the traffic is turning right, and we have say B and C, vice versa also, where we have weaving section. Here we have weaving section, and we have conflicts here. See here, here, here and here. So we have 4 sections, weaving sections, and now these are the terms that will be used while calculating the capacity of the rotary. So capacity of rotary is given by a formula 280W to 1 plus E by W to 1 minus P by 3 divided by 1 plus W by L, where P is given as proportion of weaving traffic, that is B plus C by A plus B plus C plus D. A and D is the left and right traffic, and B and C are the traffic in between. If we see an example and solve it, then we will be understanding how to calculate proportion of weaving traffic and how to determine the capacity of the rotary. Is it clear up to now? Now I will give you some data and I will solve with you, and we will determine the capacity of a rotary using that formula. So we will take simple data. So north, south, east and west. I will take multiples of 25. We have left traffic, straight and right. So I will take simple data. So I will put 250 here, straight, and 450 here, 350 here, and 550 here. Right? For simplicity, we do it like this. So left traffic I will take 25s, 525, here 575. Similarly, 425, 475, 325, 375, 225, 275. See, all the left turning traffics I have taken 25s, right traffics I have taken 75s, for simplicity only. So we have north, east and west, south approaches. How to calculate capacity for this particular rotary, for this data we will see. So first take a rhombus. And now the traffic approaching this, right? So we have left traffic from south, we have from south we have left traffic 525, and left traffic comes and goes like this. Similarly, for all the approaches we have like this. Or 25. Similarly, for this approach, and now the straight traffic 550 and 575, they'll diverge, right? They'll diverge, and the right traffic goes like this, but straight traffic goes like this. So right traffic is 575 here. It goes like this and merges here, right? Similarly, this traffic from west diverges, the traffic 250 plus 275 diverges here, and 275 goes here and merges here. So 275 is here. It turns right and goes here. Similarly, this traffic 375 plus 350 comes here, and 375 goes like this and joins this traffic. Got it? And 350 goes here. Similarly, for this approach, diverging traffic 450 plus 475 goes like this. 475 turns right and joins here and goes like this. So right traffics we have written here. In this rhombus we have written right traffics. So A and D are done. So we have A, B, and in between we have B and C. So right turning traffic and left turning traffic. So while approaching the rotary, turning right and turning left. Now I will write all the diverging traffic within brackets. So for south we have diverging traffic of 550 plus 575, right? Similarly here 450, 475. Here diverging traffic 350 and 375. Similarly here 250 and 275 is the diverging traffic. And now merging traffic, whatever it's here, for this approach it's here, for this approach it's here, for this approach it's here, and similarly here. So what is the merging traffic? We will write the merging traffic. For this approach, this one is merging traffic, diverging traffic we have written in brackets, and I will round off the traffic. So see here, this one. What is this? We have 550 going straight. So 550 and this 475 which has turned right goes like this. 475. I'll round off this converging traffic. Similarly for all the approaches. So for this one, this right and this right, 575 is going right, going here, and this one 250. Similarly for this approach, 375 is joining with 450, and this one 350 is joining 275. So we have A, B, C and D. So for this weaving section, see, for this weaving section we have A, B, C and D. So A is 525, D is 475, B and C are, one is merging traffic, one is diverging traffic. This is diverging, this is merging. So 550 plus 575 plus 450 plus 375 is the traffic at weaving section. So B plus D, B plus C divided by A, B, C, D, A plus B plus C plus D. So 525 plus, so write all these things, 550, 575, 450, 375 and then 475. So A, D, B and C as in the numerator. Now calculate P, you will get some value. So this is for south-west. Proportion of weaving traffic in southwest weaving section. Similarly, we will get P values for weaving sections east, south and northeast, and we have west to north. We will get 4 values, right? You calculate these P values. I didn't calculate, I just randomly given some data. Out of these 4 values, you have to take the maximum of P values. Maximum of P values, because we have to calculate Q, and Q for all the approaches, if P is maximum, if you take P as maximum, if you take P maximum, then you get minimum for all the approaches. So that minimum value you have to calculate. So E, we know small e as average of entry width and exit width, and width of weaving section as, if it is not given, that is E plus 3.5 meter, and WL, W by L, you can take it as 1 by 4, that is 0.25, and adapting all this data, you calculate capacity of this rotary. Is it clear? And that's it about rotary intersection. Hope you understood the concept. If at all any clarification you need, you can mail me or post in comment section.